Let's talk about AI. There are two things you can count on. One, it's absolutely everywhere. And two, the language around it is changing so fast it's almost impossible to keep up, even if you're deep in the tech world. So today, we're going to cut through the noise and break down 7 key AI terms you really need to know as this tech just keeps evolving.
And I'm not kidding when I say it's everywhere. I mean, this quote pretty much says it all, right? It's in our phones, our cars, and yeah, even our toothbrushes now. AI is just becoming part of the fabric of our daily lives.
So here's a little challenge for you. As we go through these 7 terms, just keep a running tally in your head. How many of them are you already familiar with? Let's see how you do.
Here's the game plan. First, we'll talk about autonomous agents, the AIs that can actually do stuff for you. Then we'll look at how these AIs tap into knowledge. After that, we'll get into how we're building even smarter, more efficient models. And finally, we'll look way out to the horizon at the ultimate goal of superintelligence. Ready? Let's jump in.
All right, first up, let's meet the autonomous agents. These are the doers. This is the tech that's taking AI from just being a fancy search engine to being an active helper in our world. So what exactly is agentic AI? Well, you know how a chatbot just sits there and waits for you to type something? Agentic AI is the exact opposite. It can think for itself, make a plan, and take action to get something done. Think of it like a digital travel agent that actually books your entire vacation, or a data analyst that finds insights in a report all on its own. And they do this by running in a constant loop. It's like a 4-step dance. First, they perceive the world around them to gather info. Then they reason through that info to figure out what to do next. Then they act on that decision. And finally, they observe the outcome of their action, which feeds right back into the next loop. Perceive, reason, act, observe, over and over.
But for an agent to pull all that off, to actually reason and act, well, it needs a pretty powerful brain. And that brain is built on a very specific kind of AI model. And that brings us to our next term, large reasoning models, or LLMs. These are the specialized brains powering agentic AI. You can think of them as LLMs that went to a special school for problem solving. They're trained on things with clear right or wrong answers, like math and coding, so they learn how to create an internal chain of thought, basically how to think through a problem step by step before acting.
Okay, so these agents have a brain that can think. But where do they get their information? That's what this next section is all about, the AI's library and its connection to the rest of the world.
It really starts with something called a vector database. Now, instead of just storing a picture or a block of text as a file, these databases do something really clever. They turn that data into a long string of numbers, a vector embedding. And here's the magic. That string of numbers is like a mathematical fingerprint that captures the actual meaning and context of the original data.
Here's a perfect way to picture it. Let's say you upload a picture of a mountain. The database doesn't see a mountain. It converts it into that unique numerical vector. Then it can instantly search its entire library for other images with the closest vectors. So to find other mountain pictures, sure, but it might also find pictures of hiking or climbing gear because it understands the concept of mountain.
Now, this ability to search by meaning, not just keywords, is the absolute foundation for our next term, a technique that's making AI answers way, way better.
And that technique is called retrieval augmented generation, or RAG. The big idea here is to give the AI an open book test. Before the AI ever sees your question, the RAG system first dives into a knowledge base, like a vector database, to find relevant information, and then it adds that info right into your prompt. So it's not just answering from memory, it's looking up the facts first. So the process looks like this. You ask a question. Bam! The RAG system searches that vector database for anything relevant. It finds the right info, tacks it onto your original question, and then sends that whole package to the LLM. The result? A much more accurate, up-to-date, and context-aware answer.
So if RAG is like giving an AI access to a specific library, our next term, the Model Context Protocol, or MCP, is like giving it a universal library card and an internet connection. Think of MCP as a universal adapter. It's a standard way for any AI model to plug into any external tool, databases, code, your calendar, you name it. It saves developers a ton of time because they don't have to build custom plugs for every single thing.
Okay, so we've got AIs that can act and access information. But how are we building these models to be more and more powerful without them becoming incredibly slow and expensive to run? Well, that brings us to a really clever architectural design.
It's called Mixture of Experts, or MOE.
And what's wild is that this idea has actually been around since 1991, but it's having a massive comeback because it solves a huge modern problem. The idea is to not build one single gigantic brain, but instead to build a team of smaller, specialized expert networks that work together.
So you can imagine it like a committee. You've got your grammar expert, your creative writing expert, your coding expert, your math whiz, your history buff. Each one is incredibly good at its one specific job.
But here's the genius part. When a request comes in, a smart router looks at the problem and says, okay, for this, I only need the math expert and the coding expert. It only activates the specialists it needs. This means even if the total model is massive, you're only using a tiny fraction of its computing power for any one task, which makes it incredibly efficient.
And all of this power, all of this efficiency, it's all building towards something. That brings us to our final section. And the biggest question of all, where is this all going? What's the end game?
To talk about the future, you have to know the difference between two huge concepts, AGI and ASI. AGI, or Artificial General Intelligence, is the idea of an AI that's as smart as a human, able to do any intellectual task a person can. But ASI, Artificial Superintelligence, is a whole other level. We're talking about an intelligence that's not just better than one human, but smarter than all of humanity combined. Both are still theoretical, of course.
What makes ASI so mind-bending is this concept of recursive self-improvement. That means an ASI could theoretically look at its own code, figure out how to make itself smarter, and then rewrite itself in a never-ending loop. The potential is staggering. It could solve all of our biggest problems or create brand new ones we can't even imagine.
And make no mistake, while ASI absolutely does not exist today, building it is the ultimate long-term goal, the North Star for every major AI research lab on the planet.
And there you have it, our 7 key terms. So, how'd you do on your tally? I'm really curious, after hearing all that, what's one AI term you think we missed? What should have been number 8 on this list? Let us know what you think.